Well, I was asked to discuss some issues of tack trucks and tack issues, so I'm going to go through a short presentation here. Ask questions as you need to, and we'll see what happens here. The reasons we use tack, of course, is so we've got a bonding agent. We use it as a type of glue to hold the new mat to the base. A lot of different things happen to get there because we use stronger materials are more viable when they're glued together. Temperatures are critical, and one of the big things that we run into and see out there is temperature related. Applying tack too cold and it doesn't spread out evenly and it doesn't evaporate the water out correctly. It sets up quicker if it's higher temperatures. There's a certain temperature range you need to follow, but make sure you get the right temperature so that you know what you're. I've got a few slides on that. Improper use of cleaning solvents or excess uses of a cleaning product. We refer to it as release agent number 2, aka diesel fuel, one of the most commonly used things. Also, one of the most commonly overused things. I'll cover that in this presentation as well. Improper circulation or excessive circulation will break down an emulsion. Emulsions are nothing more than a oil suspended in water and coated with an emulsifying agent to keep it there. It has a time life, and improper temperatures or improper circulation will affect that. The main thing that I run into is improper application rates because they have strainer plugged or restricted, nozzles plugged, improper nozzle sizes, and the main one is speed. Everybody tries to go too fast. By going too fast, you overdrive the nozzles. The nozzles are designed to put out a certain gallon per minute at a certain speed in a speed range. By going over that, what happens is you do not properly get the correct application due to the fact that the material will actually bypass in the distributor and go back into the tank instead of going onto the ground. So I've got a couple of different things to show you here. One of the biggest issues that we run into are plug strainers. A clean strainer is godly. You need to have that checked and inspected regularly. And there's an easy way to check it. You can physically suck everything back, look down the fill line with a flashlight, and you can see if your strainer needs to be cleaned out. If it is like the one on the right, you need to pull it out, heat it up, clean it off, use a wire brush, clean it off, and put it back in. That is the old style strainer. The one on the left is the new style strainers now, so they're corrugated differently. We also offer different strainer sizes. The key to the strainers is you want to have a strainer with the correct size holes in it that are not larger than the holes for the nozzles in the distributor, because then effectively your nozzles become your strainer and they start plugging up. So it depends on the type of material you're using and the different types of things you run into. So here's an application of a tack that's not done in a proper manner. You'll see streaking. You'll see them driving crooked. They're not covering the face of the mat. This is on a milled surface. So what about application? We offer different nozzle sizes. The nozzle sizes range from V-Tack slot nozzles with rifle board or coin slot nozzles and counterboard nozzles for tack. The application rate listed in there is gallons per square yard. And I don't use the gallons per square yard. I use the gallons per minute per foot. If you use that based on how many feet you're using, you'll come out with the correct nozzle you need. But again, the speed is critical in that one, because if you drive too fast, you overdrive these nozzles. Not only are you pressurizing the bar excessively, but you're forcing material back into the tank that needs to go on the ground. So running at the correct speed is very, very critical. One of the most common problems I see out there. as everybody tries to go too fast with the wrong size nozzles. And conversely, you can go too slow. We have an app that we offer that you can download to your smartphone. It's a pump rate calculator. You can get it at your app store. And it looks similar to this when you download it. So you can do a pump rate calculator. You put in the spray bar length, your application rate, and then you go down and you select the nozzle sizes. And then you actually physically can go in here and calculate what speeds you need to run feet per minute. If you need to do it in miles per minute, you can, but feet per minute is what we typically use. And it will give you a speed range that you can run in based on the nozzles you've selected and the amount of nozzles you have on each one. If you go too fast, or if you're going too fast, it'll show it in red if you've selected everything correctly. And this is a seal coat application nozzle, but if you put the right speed in, it'll tell you you're going too fast. It's 3002 is too fast. 300 is correct, and that's green. So that app is available. It's free of charge. Just go to your app store and download it. I use it daily. I used to use a slide rule, but now we have this, and it's easier and much more convenient, and it's much more accurate. I did find out that you do dilute some things. One of the shot rate problems we have is I don't know what your percentage of emulsion is, whether it's a 70-30, a 67-33, or 80-20, or whatever. But if you're adding water to it, you're adding cold water to an already milled product that's come from the mill already blended. When you add cold water, you run the risk of shocking the oil to the point that the emulsifiers actually start breaking down. On top of that, you change your residual asphalt rates. As you can see here, a 67-33 at a shot rate of 0.05 gives you a residual of 0.034. If you go to 0.75, your residual is 0.05. Now, if you add 50% more water to that, it changes that just completely the opposite. So you would have to spray at a 0.05, your residual is 0.017. You would have to shoot a shot rate of 0.15 to get a residual of 0.05. With that, you also got the extra water that will run off. It takes a lot longer for it to evaporate out of the system, and your residual doesn't stay in the same spots. So that's one thing to be cognizant of. I live in Illinois. They've banned us from adding any water to products. It has to come from the farm already blended with paperwork that says what the application rate is or what the residual is. So everything is done differently in different places. But I wanted to point that out. That is one thing that adding water does, is changes the actual residual rate a lot. Types of tack coat failures: you get delamination from the underlaying pavement. Some of that can be poor tack applications. It can be poor segregation. It could be a dirty underlayment where it's got a spot that's soft or something like that. Another type is slippage. You'll get slippage from excessive tack application, poor compaction, load count. You got truck traffic that runs heavy and it'd be at a stoplight or something like that. You got to go take into account all of those items. So, successful tack coat is uniform and complete adequate coverage over the entire surface evenly. I do have a video in here that I wanted to share. I ran into this situation. I had a drone out and I was following the tack guy, and he started to spray, and when he took off, he was going so fast. You can see the streaks in this. It's not an even application. The right-hand side, they had just put a hot mat down on it, so it's going to steam. But I'll run this video here, and you can see how fast he has to go. So what I did is I slowed him down, and I changed the amount of nozzles that he has. He's running all the nozzles on the bar. So I stopped him. We changed it to every other nozzle, slowed him down, and now we've got a much more even, uniform application over that tire surface there. You can see, I'll stop it right here. You can see how even that is all the way across. Like I said, this is hot, but it's still applying it to it. So it gives you an idea of what the proper way of putting tack down is. A nice, even, uniform coverage. One of the other things that we run into is excessive release agent or diesel fuel contamination. So what we have come up with is a system called Smart Clean. What it essentially is a separate tank right here. The tank is located on the side of the truck. It has a valve. There's a valve on the inlet side, and there's a return valve on the return side. Where you can either circulate a solvent, a release agent, or something in this tank through the system, whether it be just the pump or the spray bar itself, and then it will go back into this tank. So it keeps it completely separate from the distributor product. So we're not diluting the distributor tank. It's something that we are selling more and more of. So that's something to be aware of that is available today. Some of the older trucks can't be retrofitted, but the later style trucks possibly can. Some things to keep in mind is you want to keep the material at a constant temperature and do not overcirculate. One of the big things that I see as well out in the field is people will use tack and leave it in the tank for a period of time. And then they'll get a little more, or they'll spray a little more, and they're using diesel fuel to clean the system out, going back into the tank, and you're changing the pen number on the residual asphalt. So what you want to do is get that tack out of the tank as often as possible and refresh it. Try to keep it in there for a minimal period of time. The more you heat it, the more you circulate it, the more risk you run of breaking it down and separating the product in the tank. The suck back the spray system is very critical. People tend to suck back quickly, try to think they're getting the things done. I like to recommend running it for longer than you think. It doesn't take that much time. And then minimize the release agent or diesel or solvent or whatever you're using when flushing. There's a small amount of material that you need to use. The other thing is when you're using tack at a lower rate per day and you're cleaning this bar back all the time, you're running more solvents back into the material. So it does break the material down. Surface prep before you tack. One of the biggest things that we find: sweep, pick up broom, water or mist, clean, 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 dry and damp. Everybody says you need it dry. To a degree, that's true, but it can be a damp surface. If you're on a milled surface, a slightly damp surface will actually absorb the tack more into the base product than it will on a dry surface, because the dry also leaves the material clean. The cleaner the surface before the tack, the better the bond. Here's an example of tacking over dirt, basically a very dirty surface. One of the other things that you can note in here is you can see the surface going to be bonded to is not completely covered. One slide I was looking for that I couldn't find was we have people that will put a small piece of pipe and a nozzle with a 45-degree angle on it and spray the face of that with one nozzle. It makes a pretty good surface on the face of that material. So, but clean the surface up, because all that's going to happen here is you're going to have delamination from the material underneath. You got to have it clean, otherwise it doesn't bond. This is one of our older distributors. This is the DC2 SX2 computer. One of the biggest problems we run into this one is this switch right here is circulation rate. People tend to circulate too fast. They run the materials, they take off, and they're circulating at 100 or 120 gallons a minute, and they get initial surge and they get a big wave of oil. You need to figure out what you need to start at. So changing the circulation rate on this machine is critical to getting the proper application at the beginning. The computer takes over after it begins, but it's that initial, we call it the Valdez at the beginning. Our current replacement for the DC2 SX2 is the BT1 control box. This is the front box here. We have a lot of these out there. These will be in service for many years to come. And then this is the rear box. So our current one now is a touchscreen control. It has a self-diagnostics on it. It's a lot easier, more user-friendly. There's a lot of different things. So this is the front box, and this is the rear box. It mirrors the front screen, so everything is the same front and rear here. One of the most common problems I run into is people see their tank gauge at the back and they go by that one filling, so they take enough material out and it's full, but they don't stick the tank to see what is actually in that tank with a stick that's certified for that tank, and then adjust that, because people grab that, it moves, it's designed to move so it doesn't break the shaft. You need to also calibrate that I tell people to calibrate once a month at least. Just driving down the road can cause that to move with the material in it. Somebody inevitably reaches up and grabs that because the tank valve is stuck to the bottom of the tank, and then it's off. So if you're going by the tank gauge, it could be incorrect if it's not correctly calibrated. Use of accessing cleaning solvents changes the physical properties of the final asphalt products. Improper application, speed, application rate, and nozzle size, and does not create a proper bond to the asphalt. One of the other things is you use the cationic emulsion, a CRS2, I believe is what Sharon shared with me. One of the things you should do is circulate some type of a bonding barrier agent inside, like a hot oil, in your tank. Cationic emulsions are blended with hydrochloric acid. Hydrochloric acid left in a tank will actually eat away at the metal. It eats away at the metal in the bar, the joints, and the tank itself. I've poked holes in the back of heads of trucks that have been material left in them for a long period of time, like over winter or something, and that fumes from the cationic emulsion, the hydrochloric acid, actually will etch away at the tank and eventually eat holes in it, or the bar system or anything else. So if you circulate a barrier of hot oil or something inside a tank prior to using it, let it set and cool down, you can use that tank all summer long. Conversely, at the end of the season, you need to clean that tank out. And people that don't have the availability to flush it with a hot material, that's fine, but you can flush it with just plain water. Water will dilute the hydrochloric acid and stop the eating of the tank. Improper suck back and clean out creates an atmosphere that causes possibility chemical reactions as well to parts of the tank. Neutralizing chemical reaction reduces expensive repairs down the road. But the most critical is proper application of products used ensures you meet specifications designed to meet the job requirements. I like to end what I'm saying here with a short video that shows something that shouldn't do, both for engineers or people on the road. Don't park too close to the road, but for contractors not to bypass safety equipment. And I'll just show this quickly and then we can get to the end here. They were spraying the shoulder with a fog seal along the interstate, and the brand new truck was parked along there, and they had the safety bypass for the wings, so they just painted the truck black. And I hear a lot of comments when I see that, but I wanted to share that. So I have nothing further. I would be willing to take any questions along the way, or you can feel free to contact me. This is my email address here, my cell phone. We are Etnier International now rather than the E.D. Etnier Company. We have several companies now. In 2023, we celebrated 125th anniversary. So we've been around for a while.